So without further ado, we will start our first panel, the panel on energy efficiency and renewable energy sources and urban solution. Well, energy and society of sustainability is one of the most important topics. We know that successful transformation to low emission or no emission production is a key goal. Our panelists will show a number of ways of how we can achieve such transformation faster, cheaper, or cleaner. So our first panelist is Gabor Molnar, geothermal engineer at Mannvit Engineering, Iceland. Gabor, please.
Thank you very much, Nikita, and good morning to every listener. I'm Gabor Molnar from Mannvit Engineering office, located in Iceland. Actually, I'm talking from Hungary, from the Hungarian office of Mannvit. I'm geothermal engineer, participated in several geothermal energy projects in the past decades. And I would like to give you a brief overview about geothermal energy. Where is geothermal energy in the role of renewables? We can compare it, for example, by the CO2 emission of the life cycle of the projects. Geothermal energy is in quite a good position. It has low CO2 emission during installation, during operation, and during abandoning of the plants. We can compare by the financial feasibility. It has good feasibility, it has low payback time, but it all depends on the energy amount what can be harvested from the earth, with one of the main parameters of the energy amount is the temperature. And this is what I would like to show you today, that the geothermal energy is basically available anywhere in the world, but it depends on the temperature, and different temperature can be utilized by different technologies. And I will show you a brief overview about the different technologies. Usually, groundwater above 30 degrees is called to be thermal water or geothermal brine, which doesn't mean that the colder temperatures are not useful. Cold waters or low temperature brines could be used by geothermal heat pumps, even by large district heating systems, or even by large infrastructural or industry projects. The medium temperature range is very widely used for heating, and the highest temperature ranges above approximately 100 degrees plus minus could be used for electricity production. There are good examples in Europe for this. I will start with the medium temperature. That's the most obvious and most widely spread utilization of the geothermal energy. Most of us may know the famous Lindell diagram, which shows several types of utilizations or technologies that requires heat. Here are a few examples. On top of this list there is district heating. Very large systems could be heated by geothermal. Good example is Reykjavik in Iceland, which is fully heated by geothermal, and something similar is starting now in Budapest. Just a slide about it. There are a very scattered existing distribution system in Budapest in Hungary, and there are different temperatures, different reservoirs under the city. So there will be a combination of the different technologies and different energies implemented. I hope then in 1 year time I can show you some good examples or good results about this project. The lowest temperatures could be directly used. Cold water can be used for cooling. That's very obvious or evident solution, but still it's very rarely used. It's maybe because the very thin window of temperature where the cold water could be used directly for cooling, 5 to 15 degrees Celsius could be used. But that's a very efficient solution, and could be used more than today. But still, what is really used, especially in Germany, there are a lot of good examples for large-scale geothermal heat pump system. Even the high temperatures, like 80 degree, could be used for heat pump system, and the temperature could be increased more and it can heat up even a large district heating system, as I mentioned. And the COP, the efficiency ratio of those systems are very good, can be even 8 or 9 or COP. So very efficient system could be installed by utilizing low or medium temperature geothermal brines for providing energy, heating energy. Another technology is the borehole system. Everybody knows the family house scale heat pump heating system, where a 100-meter shallow well harvesting 10-15 degrees Celsius heat from the ground, and some heating and cooling could be provided by this technology. It has some efficiency, it has some payback time. In most cases, it's questionable if it's worth or not without any subsidy. But it can be implemented in large scale also. If you have, or someone has a unused geothermal well, or a dry geothermal well, or a dry old hydrocarbon well, double pipe or a borehole heat exchanger could be installed into it. That's not a new technology, but it's now it's not under development. So there are some examples. There is one power plant like this or heating plant like this recently built in Hungary, but there are a lot to do. It has low efficiency, but if a driver could be utilized, then it's a very good solution to install a heat exchanger like this into the well. And yeah, there are the high temperature utilizations. High temperature is appropriate for electricity production. The conventional way is to build large-scale power plants. There are 200, 300 megawatts geothermal power plants in Iceland. There are large power plants in Turkey, in Italy, which uses geothermal brine above 120, 130, or even 200, 300 degrees Celsius temperature to generate electricity. There are several manufacturers who provide solutions, tailor-made solutions for geothermal electricity generation power plants. They are in most cases EPC contractors, so design and build the power plants. It has good efficiency and very good life cycle feasibility, CO2 emission reduction. Another way, that's the large industrial scale. But there is a kind of a new development of geothermal electricity production is the modular technology, which are now offered by several manufacturers in the world, in Europe. And because the main idea is to make it smaller, make it as optimal as possible, and then results a very good efficiency even in low temperature ranges. So electricity production from 80 degrees Celsius is possible. In most cases, it's not feasible economically, but from 100 degrees, it is feasible and economically, technologically feasible, and not only from geothermal resource. This technology can utilize waste heat of an industry process or heating systems, and that's why it's a very rapidly spreading technology for electricity production, small scale electricity production. So I'm talking about some 100, 200 kilowatt electricity production per unit, but they can, as you can see in the picture, they can installed in a row, so it can multiply. That's kind of a very good amendment for any already operating geothermal system, heating system in small industry scale also. It is possible to use. But what makes the geothermal energy really sustainable or feasible? That's the combination of the different technologies. As you can see in the graph, the heating system, of course, adapting to the weather conditions. So in the winter, there is high heating demand. In the summer, there is almost nothing or low. And the rest of the heat amount that can be harvested from the earth could be used for any other purpose, like electricity production or heating for any other technology processes. And the key of the sustainability to reinject or just let to flow away as low temperature as possible, and then this means you can harvest or you can utilize a large amount of the harvested heat. If just talking from the other way around, and that's a very common solution. If there is a geothermal power plant built on a high temperature resource or even a low temperature as shown above, in most cases the brine should be reinjected into the ground. But still, in this brine, what is coming out from the power plant has some 60 to 80 degrees Celsius temperature, so it can be utilized further, for example, for agriculture, heating greenhouses, soil heating with low temperature. Another possibility of utilization of the outflow temperature is to use in district heating system, heating houses and or generating tap water for houses or using spas. And still the geothermal brine has some 30, 40, 50 degree Celsius temperature, and it can go to several purposes like spas, or in this example, some fish farms or hydroponic systems. And this ensures the highest amount of energy gathered from the same resources. And also, that's a very common issue with geothermal systems. There are some gases in the brine, or there are some steams in the brine, which also could be utilized. If there is methane, it can be used in gas engines. If there is CO2, then it can be used in the greenhouses, agriculture. So a very feasible and combined system could be built on the geothermal resource. And this is the main intention of not only the engineers like us, but the investors also, to utilize the energy as efficient as possible. And geothermal energy is very much appropriate for this. Yeah, that's it. I think I'm in the time frame. Thank you very much for watching this. And if you have any question, just feel free to ask.
Thank you very much, Gabor. There are questions actually that are connected to the Czech Republic and the Czech Provenience. What are the options for geothermal energy system in the Czech Republic?
Well, yes, in the Czech Republic there are what I've shown in the medium temperature range. In some spots there could be high temperature harvested, but in most of the Czech Republic is appropriate for geothermal heating for sure, for heat pump utilizations for sure, maybe for low temperature electricity production systems. So yeah, geothermal energy could be developed and implemented in the territory of your country.
And how large is the potential? So if you talk about maybe neighboring countries, or if you put it in a context, because you've shown some use case, but if you look at it from maybe a big picture of this region, how can we achieve using these concepts even more? What is the future, even in terms of maybe some support of this geothermal energy from the European perspective?
Yeah, I just put back this slide which shows the map of Europe. Of course, the prospect of Czech Republic is not comparable with Iceland, where there is high temperature just near to the surface. And also Hungary is in a very lucky situation regarding geothermal energy, because it's available in high temperatures, available in shallow depth. But it's Czech Republic is somewhat comparable to the most of the Europe. And the best example is Germany, where there are very large geothermal systems and also geothermal power plants in operation. You have to drill down to 2, 3, or even 4 kilometers to the ground to harvest large temperatures for electricity production or for heating. But still, it's feasible. It also depends a little bit on the energy prices, which are very high in Germany, and there are governmental intentions to implement renewable energies, especially geothermal energy. But with proper governmental directions or legislation, it could be implemented in the same way as in Germany.
We touched upon governmental support. My next question, basically, in order to maybe roll this out, scale it, somehow you need governmental support on European level as other renewable sources. Do you see this changing in terms of geothermal energy? You named Germany, but what are tendencies in other countries?
I think, yes, it can be clearly seen that the European Union has this intention to increase the support for renewable energies, and geothermal energy is one of the prioritized energy types. It's developing slowly, I can say, but it's developing. Geothermal energy, I think it's true for any kind of renewable energies. They are and they have to be feasible without governmental supports, because otherwise they are not cannot live in the market. But of course, any support or any subsidy can facilitate the developments, and this is what's happening. Supports can speed up the developments and larger scale projects to build up.
Gabor, thank you very much. Thank you for your insights.
Thank you very much. Thank you for listening.